All right, so our universe is about 15 billion years old, and that's when all this sort of gaseous material coalesced, and we started to form the universe. And then as material was coming together about 5 billion years ago, the planets formed. So 5 billion years ago, the planets formed, and they had some very light elements. So if we were to go back to that periodic table, and I'd said the identity of an atom is determined by the number of protons that are present in their nucleus. And if you were to say, okay, so one proton, what element is that? I'm so interested. You're not probably, but what is it? It's hydrogen. Then two protons, helium, and so on. So we have all of these different elements, and I'd said the number of protons determines the identity of the element. And so the earliest, right after the Earth formed, there were gases that were produced, but they didn't stick around because they were so light, they were lost into space. And so the Earth, if you think about the moon, if you watch the guys, videos of the people walking around on the moon, there's no atmosphere there. It's a small planet. So that's the way the Earth was. But then what happened? We had this mass of molten rock and all of this material in the core of the Earth, and it was spewing out of volcanoes. And the volcanoes were releasing things like carbon dioxide. And so carbon dioxide, it's heavier than that helium and hydrogen. Carbon has an atomic number, has 6 protons. Oxygen has 8. So combined together, this compound, it's big enough that it stuck around. And why did it stick around? Because of gravity. Now, gravity is such a bizarre concept, but I'm going to mention it just because it's interesting, quite honestly. So you might wonder, what is gravity? What is going on? So what happens is the universe is full of something called antimatter. You can't see it or really tell anything about it, but it's like the analogy they use is a trampoline. And so if you had a trampoline like people have in their yards, and if you were to put a golf ball in the center of that trampoline, and you were to take a marble and you roll it towards that golf ball, it just roll right past it, right? I mean, because the golf ball doesn't have much mass, so it doesn't weigh much. Now, if you were to take a bowling ball and you put it on that trampoline, it would bend the trampoline sort of downwards. And that's what mass does to antimatter. So antimatter is this invisible stuff that's kind of like a trampoline. And if you have a large mass, it bends the antimatter. And so now, if you were to take a marble and roll it towards that bowling ball, if it's the right speed and the right distance from the bowling ball, it would get caught by that curvature that resulted from the mass of the bowling ball, and it would circle around it. It would be attracted to it. Well, that's what happens. So we have gravity, and that's the way they explain it. I'm not a physicist, but I do find that fascinating. That's how they explain it. And so the early atmosphere was carbon dioxide. It wouldn't be good for you and I. But if you've had a biology class, you might know who it would be good for. Plants. Plants photosynthesize, and where do they get the carbon to build the sugars and other molecules? From the air, carbon dioxide. So we had this carbon dioxide environment that then gets converted when plants we had said a little bit ago, you and I breathe in oxygen and we exhale CO2. Plants don't have lungs, but they take in carbon dioxide, and you know what they release? Oxygen. That's right. Oxygen is released. So because of the photosynthetic organisms, we started to increase the oxygen in our atmosphere. And so we gradually went from a CO2, a carbon dioxide atmosphere, to one that has a lot of oxygen in it. Okay, I'm going to stop right here.